Ever looked up at the night sky and wondered, what are the chances of a giant rock wiping us all out? Well, buckle up, because NASA has some news. A 370-foot-tall asteroid, the size of a skyscraper, is hurtling towards Earth at a mind-blowing speed of 33,673 kilometers per hour. Should we be stocking up on freeze-dried food and building bunkers? Stay tuned, because we're about to separate fact from fiction and explore the truth behind this cosmic cliffhanger. First, let's take a closer look at the asteroid itself. Known as 2024 QL2, this massive space rock is an impressive 370 feet in diameter. To help visualize its size, consider this. It's comparable to a 37-story skyscraper, or nearly as tall as the Statue of Liberty. Imagine a structure of such magnitude traveling through the cosmos. The sheer size of 2024 QL2 is enough to grab our attention. But there's more to this celestial giant than just its dimensions. Asteroids like 2024 QL2 are remnants from the early solar system, composed of rock, metal, and sometimes ice. These ancient objects can provide valuable insights into the formation and evolution of our planetary system. However, when they stray close to Earth, they become more than just subjects of scientific curiosity. Asteroids vary widely in composition. Some are mostly rock, while others contain significant amounts of metals like nickel and iron. A few even harbor precious metals like gold and platinum. 2024 QL2, based on its size and trajectory, likely falls into the category of near-Earth objects, or NEOs, which are asteroids and comets with orbits that bring them close to our planet. Studying these NEOs is crucial for several reasons. First, understanding their composition helps scientists devise potential deflection strategies. Second, by examining these space rocks, researchers can learn more about the building blocks of the solar system. Each asteroid is a time capsule, preserving the conditions from billions of years ago. Surface features on asteroids like craters, ridges, and grooves can tell a story about their history. For example, the presence of craters indicates past collisions with our celestial bodies, while ridges might suggest tectonic activity. These features are not just fascinating, they also help scientists predict the behavior of asteroids when subjected to forces such as gravity or an impact. Let's explore the astounding speed and trajectory of 2024 QL2. Traveling at 33,673 kilometers per hour, this asteroid moves over 27 times the speed of sound, highlighting the urgency of accurately tracking its path. At such speed, even slight miscalculations can have significant consequences. NASA uses advanced technology to monitor 2024 QL2, employing ground-based telescopes and space-based observatories to chart its course and ensure it stays at a safe distance from Earth. An asteroid's trajectory is influenced by gravitational forces from planets and other space objects. Continuous monitoring is essential, as even a small gravitational nudge can alter its path. The more data we collect, the better we can predict its future movements. NASA's Near-Earth Object Observations, or NEOO program, leads this effort. By scanning the skies and cataloging thousands of asteroid orbits, the NEOO aims to detect and track potential threats. Advanced radar systems and optical telescopes provide detailed information on speed, direction, and potential impact points. Through these tracking methods, NASA has calculated that 2024 QL2 will safely pass by Earth. However, the exact distance can vary due to gravitational interactions. So the agency continuously updates its predictions to promptly address any changes in the asteroid's path. Understanding the speed and trajectory of 2024 QL2 is crucial for assessing immediate threats and improving our ability to monitor and respond to similar objects in the future. Each day, we gain more knowledge and enhance our preparedness to protect our planet from space dangers. NASA's effort begins with the diligent work of astronomers who continuously scan the skies. Ground-based telescopes, such as those part of the Catalina Sky Survey in Arizona and the Pan-STARRS in Hawaii, are crucial for detecting near-Earth objects or NEOs. These telescopes are equipped with high-resolution cameras that capture images of the night sky, allowing astronomers to identify any new objects or track known asteroids. Once an asteroid is detected, astronomers use a process called Astrometry to determine its position and movement. By taking multiple images of the asteroid over time, they can calculate its orbit and predict its future path. This is where space-based observatories like NASA's Neowise come into play. Neowise, an infrared space telescope, scans the sky in search of asteroids and comets. Unlike ground-based telescopes, Neowise can observe objects in the infrared spectrum, detecting heat emitted by these space rocks. This capability is especially useful for finding asteroids that are difficult to spot with visible light due to their dark surfaces or distant orbits. In addition to optical and infrared observations, radar systems play a vital role in tracking asteroids. The Goldstone Solar System radar in California and the Arecibo Observatory in Puerto Rico, before its collapse, have been key assets in this effort. Radar observations allow scientists to create detailed models of an asteroid's shape, spin, and surface features, providing a more comprehensive understanding of its physical properties. Using this wealth of data, NASA's Jet Propulsion Laboratory, or JPL in California, runs complex simulations to predict the orbits of newly discovered asteroids. These simulations take into account the gravitational influences of planets and other celestial bodies, ensuring that the predicted paths are as accurate as possible. All of these efforts are part of NASA's Planetary Defense Coordination Office, or PDCOO, established to detect, track, and characterize potentially hazardous asteroids and comets. The PDCOO also develops strategies for impact mitigation, ensuring that we are prepared for any potential threats from space. As we continue our exploration of the universe, the work of NASA and its partners around the world remains essential. Their dedication and expertise keep us safe and informed, highlighting the importance of continued investment in space research and planetary defense. Join us in our next segment as we delve into the potential impact and consequences of an asteroid collision with Earth. We'll explore the science behind these events and the measures being taken to prevent them. Let's focus on the potential impact and consequences of an asteroid like 2024 QL2 hitting Earth. Such as an event would be both fascinating and sobering. A collision with a 370-foot asteroid would release immense energy, comparable to multiple nuclear bombs. The effects would depend on various factors, including the asteroid's composition and impact angle. If it struck a populated area, the devastation would be immediate and extensive. Buildings flattened, infrastructure destroyed, and many lives lost. The shockwave would cause severe damage over a wide radius, and the generated heat could ignite widespread fires. An ocean impact would be equally catastrophic, displacing massive amounts of water and creating tsunamis capable of traveling across entire oceans, inundating coastal regions, and causing widespread destruction. A significant impact could also trigger global climate effects. Dust and debris thrown into the atmosphere could block sunlight, leading to an impact winter, disrupting agriculture, causing food shortages and humanitarian crisis. Historically, large asteroid impacts such as the Chicxulub event 66 million years ago caused massive extinctions. While such catastrophic impacts are rare, they remind us of the potential threat asteroids pose. Fortunately, events of this magnitude are infrequent, and smaller asteroids like 2024 QL2 are less likely to cause global extinction. To mitigate these risks, NASA and other space agencies are developing strategies to prevent or minimize the impact of collisions. The DART mission aims to test our ability to deflect an asteroid by crashing a spacecraft into it, altering its trajectory. Thank you for joining us on this journey through space and science. Be sure to like, subscribe, and hit the bell icon for more fascinating updates on space exploration and astronomical events. Share your thoughts in the comments below and click the next one shown on the screen. I'm sure you like it. Thanks for watching.